Okay, so let's talk about approaching a synthesis problem. So in order to approach a synthesis problem, first thing you've got to do, you've got to ask yourself, are there any changes in the carbon skeleton? If there are, we know we can increase the carbon chain by using acetylide, right? Okay, that will increase it by the number of carbons that are in R. Or if we need to decrease it, we can decrease it with ozone, right, in DMS or zinc and water. Remember this reaction? Okay. So first thing, are there any changes in the carbon skeleton? And you do that by numbering the carbons with your pencil, right? Don't do it with your eyes. Number two, are there any changes in the identity and or location of the functional groups? So solving a synthesis problem requires the recall of all the reactions that you have and working through lots of examples. So two carbon atoms can be introduced by alkylating the starting alkene, right? Remember two steps here. First of all, you strip off the proton with the strong base, right, which is a non-nucleophilic base. And then after you do that, you add a haloalkane. So in this case, it's iodoethane, right? And there's my ethane, right? There's my ethane, see that? And I've added two carbons to it. This is two steps. And then finally, if you want to take this to an alkene, then you can take it to a transalkene by using the dissolving metal reduction. Okay, so this is actually three steps, as you see, right? But we call this really one step because really your purpose is to increase the carbon chain. We call that one step. It's really two reactions. Here's another reaction, and I want to emphasize, you could do your synthesis like this, but it's very important that you number these reactions. You can't just put them all together, because if you put them all together, it's going to look like you're putting the metal in with this, which is those two go in the same batch. It's simply not going to work.